Hello, 6th grade math students. Welcome to Chapter 11.1, in which we begin Chapter 11, which is all about the circumference and area of a circle. Lesson 11.1 will help us to identify the parts of the circle, beginning with the radius, diameter, and circumference. Let's get started. Let's begin by simply looking at this shape that you've known about for years. It's a circle. You can use a compass to draw a circle. What I want you to note that as you're drawing your circle with this compass, all of the points of the circle are the same distance from the center. O, as marked here, is the center of the circle. Line OP, right here, that's called the radius of the circle. The radius of a circle is the line segment that connects the center to any point on the outside edge of the circle. Lines OQ and OR are called the radii of the circle. That's spelled like this. And it's the plural of radius. Okay. And finally, lines OP, OR, and OQ are all equivalent in length. So every radius of the circle, all three radii, are equal in length. Let's take a look at another circle and identify its parts. In this purple circle, the O is the center. Line segments PQ and RS pass through the center, O. PQ is called a diameter of the circle. A diameter of a circle is a line segment that connects 2 points on the circle and passes through its center. Line TU is not a diameter because while it connects 2 points on the circle, it does not pass through the center. So in this particular circle, our radii would be labeled as OP, OQ, OR, and OS, correct? Those are all radii, and they're all of equal length. Line RS and line PQ are both diameters, and they are also equal in length. A quick thing to note when you're calculating, the length of the diameter is equal to 2 times the radius. Here are your first 3 practice problems for this chapter. In number 1, you see a circle. Please name all of the possible diameters that are drawn here, and then please name which line that is not a radius is not a diameter. Explain why that line is not a diameter. In problems 2 and 3, you're given the radius and asked to find the diameter, or given the diameter and asked to find the radius. Press pause while you work. We have more to learn after this. The next vocabulary word I'd like us to learn about is circumference. The circumference of a circle is the distance around the circle. So if we're to look at this circle here, the measurement that we would call the circumference would be taken if we could take a ruler or a measuring tape and lay it down flat all the way around the edge of the circle. That distance is called the circumference. There is a predictable relationship between the circumference and the diameter of a circle. Let's explore that relationship now. Because once you understand that relationship, you'll see that there's an easy formula to use to calculate the circumference of a circle. So let's take a look at each of these circles here. One is 2 centimeters in diameter, then we go to 3, 4, and finally a 5 centimeter diameter circle. Let's imagine that we could use a string to measure the circumference of each circle to the nearest tenth of a centimeter. I'm going to do that and record it on a table here. Okay, here we go. Here's our data. So circle A with a diameter of 2 centimeters has a circumference of 6.2. Let's discover what the relationship is between the two by dividing the circumference by the diameter. What is 6.2 divided by 2? It is 3.1. Okay, let's look at circle 3. When the diameter is 3, the circumference is 9.4. Let's find the relationship by dividing 9.4 by 3. When I round my answer to the nearest tenth, I get 3.1. Okay, interesting. Now let's look at circle C, which is 4 centimeters across. Its circumference is 12.5. When I divide that by 4 and round my answer to the nearest tenth, I get 3.1. And let's look at circle D with a diameter of 5 centimeters, a circumference of 15.6. When I divide the circumference by the diameter and round that answer to the nearest tenth, I get, you guessed it, 3.1. All right, so the circumference of any circle divided by its diameter always gives the same value. And hey, guess what we call that value? We call it pi. All right? So notice that this is an approximation of pi, because as you are all well aware, pi goes on to infinite digits. So whenever we talk about using pi in math, in this case we're using 3.1, we would call that an approximation of pi, because we can't ever use pi exactly. Let's learn what we've just discovered to write 2 different equations we can use to find the circumference of a circle. Because when we took the circumference and divided it by the diameter, our answer was pi. We know that if we know the diameter and we know pi, pi times diameter equals circumference. What if you don't know the diameter and you only know the radius? Well, then you would take 2 times pi times r to find the circumference. Okay, so there's 2 possible ways to solve. Pi times diameter or 2 pi times the radius. Okay, so let's do this. Let's find the circumference of a circle. The plate shown here has a diameter of 28 centimeters. Our directions tell us to use 22/7 as an approximation for pi. Okay. You'll notice that sometimes the book asks you to use this fractional form, 22/7, and sometimes it asks you to use 3.14. Go with what the book says. There's usually a reason for it, and as we work examples, you'll see how and why you might want to use one or the other. Okay? So if our circumference of our circle is equal to pi times diameter, let's plug in what we know. We've been told to use 22/7 as our approximation for pi times the diameter. Now, I bet you can see right away why the book is suggesting you use 22/7 as your approximation for pi, because you can cross-reduce this, giving you a very quick and easy calculation of 22 times 4 equals 88 centimeters. So the circumference of our circle for our plate is 88 centimeters. Let's work another problem using radius. The radius of this bicycle wheel is 10.5 inches. Find the circumference of the wheel. Use 3.14 as an approximation for pi. Okay, so if we have a circumference, or excuse me, if we have a radius, we'll calculate the circumference using 2 pi r. So our circumference is going to equal 2 times, and remember the problem told us to use 3.14 as our approximation for pi, and our radius is 10.5. All right, you can see here that 3.14 is a better number to use because we can't reduce at all. So just go ahead and use decimal to decimal as we're multiplying, rather than mixing your fractions and your decimals or having to convert one to the other. All right, so 2 times 3.14 times 10.5, please do use your calculator for that, is 65.94 centimeters. So the circumference of our bicycle wheel is 65.94 centimeters. Here are 2 practice problems for you. In problem 4, copy and complete the table using 22/7 as an approximation for pi. And in problem 5, do the same, but use 3.14 as an approximation for pi. Please note that you can use your calculator for number 5. I suppose you could use your calculator for number 4 too, but you probably won't need to. These numbers should reduce pretty nicely with 22/7 as your approximation for pi. Now that you're circle experts, let's start discussing semicircles and quadrants. You can divide a circle into halves, of course. When we take a look at this halved circle, we would call this section a semicircle. Line ABC would be called the arc. It's called a semicircular arc because it's an arc on a semicircle. All of these words make perfect sense, don't they? I love it when the math works that way. We can also divide a circle into quarters, like this. Each quarter circle that results is called a quadrant. Line PQR is also called an arc. Of course, we call this an arc of a quadrant because it is the arc of a quadrant of the circle. The arc of a quadrant would be 1/4 the circumference of the circle, and the arc of a semicircle would be 1/2 the circumference of the circle. So let's work a problem using that information. Let's say we have a length of wire and we bend it into a semicircular arc. The length of line EF is 21 centimeters. Let's find the length of the wire. We're going to use 22/7 as our approximation for pi. All right, so we know the circumference of our circle is going to be equal to pi times the diameter, correct? We've been told to use 22/7 as our approximation for pi. We're going to take that times our diameter, which gives us a radius of a circumference of 66 centimeters. The length of a semicircular arc is 1/2 of, remember of is code for times, 1/2 of the circumference. Therefore, the length of our arc is 33 centimeters. So our length of wire from here to here is approximately 33 centimeters. Now let's work an example using a quadrant. A circular ring of radius 5 inches is cut into 4 equal parts. Find the length of each arc of a quadrant. Use 3.14 as your approximation for pi. All right, so we know the circumference of this circle will be equal to 2 pi r, correct? Because we only know our radius. So we're going to take 2 times 3.14 times 5, which gives us a circumference of 31.4. Okay, we're finding the length of an arc of our quadrant, so that is 1/4 of 31.4, 1/4 of our circumference. 1/4 of 31.4 is equal to 7.85 inches. So the length of each arc of our quadrant, so the length from here to here, is 7.85 inches. We have a couple of final practice problems to wrap up chapter 11.1. I'm going to talk you through number 6, at least how to set it up, and then leave you to do the calculations, okay? So here's number 6. A circular hoop is cut into 2 equal parts. Its diameter is 35 inches. Find the length of each semicircular arc. Use 22/7 as an approximation for pi. Okay, so here's how I would set this problem up. First, I draw a circle. And as always, please excuse my not so great artistic skills. So our circular hoop is cut into 2 equal parts. All right, I'm going to cut it in half. The diameter is 35 inches. Okay, let me label that. Find the length of each semicircular arc. Use 22/7 as an approximation for pi. Okay, now you have all the information you need to solve that problem. You know the diameter, you know the value of pi, and now you can calculate the length of this semicircular arc. All right, now let me give you number 7. The picture's already drawn for us for number 7. Whew, saved from my art skills. A quadrant is cut from a square. The side of the square is 10 centimeters. Find the length of the arc of the quadrant using 3.14 as your approximation for pi. Okay, so they don't tell you this directly but I think you could probably figure this out on your own. However, I'm going to tell you just in case. I don't want you to be confused. If the length of our square side is 10 centimeters, then the length of our radius is 10 centimeters, right? Okay? Because it's a quarter of our circle, you can see how it fits into the square there, that the radius is going to be 10 centimeters, just like the edge of the square is 10 centimeters. All right, from there you know what to do. 2 pi r equals your circumference. Divide by 4 to get the length of your semicircular arc. All right, I hope you are having just as much fun with circles as I am. I love learning about circles. When I see you tomorrow, we'll dive more into finding area of a circle, which is lots of fun. See you then.